Alright, you just completed a worksheet on completing the square, and we're going to go ahead now and apply that into the world of solving quadratics. So, if we look back at what we've done up to this point with solving quadratic equations, we've had two methods we've used so far. Method number one was the square root method, where you solve for x squared, take the square root of both sides. Method number two is factoring, where you factor down and use the zero product property and set each equation equal to 0. Well, let's look at a new example here. X squared plus 10x minus 6 equals 0. And if we look at this problem and we look at the square root method, we know the square root method doesn't work when you have this x term in the middle. So we know that won't work. And when you try to factor that, you're looking for numbers that add to 10 and multiply to negative 6. Obviously, there's nothing that meets that requirement. So therefore, we need a new method. And this is where we've talked about the square root method's very nice, so is factoring, but they're both limited. They don't work all the time. So we're going to move on to a new method now that will work for any quadratic equation. You can use it all the time. And that new method is going to be called completing the square. Hopefully what you did yesterday or earlier today in that worksheet was fairly easy for you to figure out what would make something into a perfect square, and then you were able to factor it. Well, we're going to use that same concept here to solve a quadratic equation. Now we're going to start with a simple example that is factorable, because we always want to check and make sure that our method works for all of our equations here. So I went ahead and did the work here for our factorable example of x squared plus 4x minus 12, and the numbers that multiply to negative 12 and add to 4 are 6 and negative 2. So I factored it, I applied the zero product property, and I got x equals negative 6 and x equals 2. And so we went ahead and did this so that you can see that this example will get the same solution by using what's called completing the square. So we're going to go ahead and solve this exact same problem with another method showing that we will get x equals negative 6 and x equals 2 for our solutions. So to begin with, to complete the square, we want to make our problems look like what we did yesterday. Yesterday we filled in blanks with values that completed a perfect square. So therefore we need that constant term to go away. We need that to move over to the other side so that we can equal to 12 and complete our square by filling in the blank. From the worksheet you just did, we should be able to hopefully recognize that our square would be completed by plugging a 4 into our blank. And when I do that, here's the only thing that's going to be different or kind of new today, and actually it's a very old concept for you, but it's just different than what we've done. If I fill in a 4 on the left side of the equation, I've changed the problem. And in algebra, we have to maintain equality. And so therefore, if I've added 4 to the left side of the equation, I also have to add 4 to the right side of the equation. So you need to remember, whenever we are completing the square, whatever we plug into the left side, we must also plug into the right side in order to maintain equality. So now, based on what you did yesterday, we can look at that x squared plus 4x plus 4 and factor that, and say that x plus 2 squared equals 16, and the 16 comes from the 12 plus 4. Now, the reason why we complete the square is we're turning every problem into a square root method problem. So this is its own method. We called this method number 3, but it really is just taking us back to method number 1, which was the square root method. Because I now have a perfect square equal to 16. So if I want to get rid of that square, I take the square root. That's what our square root method says to do. And now a square root and a square are opposite operations. So therefore, on the left side, I'm left with just x plus 2. On the right side, when I take the square root of 16, I get plus or minus 4. We need to make sure we remember, whenever you take a square root method, you're going to get a positive and a negative solution. The only difference here between our original square root method and completing the square is we're not solved for x. We still have x plus 2 on the left side. So we need a minus 2 from both 4 and negative 4. So we do 4 minus 2, giving us 2, and negative 4 minus 2, giving us negative 6. So there's our two solutions that match exactly with what we got above here. and we look at those same values, x equals -6, x equals 2, we got those same solutions using both methods. So completing the square does work. So let's go ahead now and look back at our original problem that we could not solve on our first screen. We had the equation x squared plus 10x minus 6, and we said you can't solve that with the square root method, you can't factor it. So let's look at another method for solving. Our completing the square method. We always start by creating that blank, just like the worksheet you did earlier today. We create that blank by moving the constant term over to the right side. So I add 6 to both sides. Now, when I go to complete the square, I'm going to plug into that blank half the middle term squared. So that's going to be 25. But again, I have changed the problem. If you change the problem, you must do it equally to both sides. So if I added 25 to the left, I must add 25 to the right. Now, I look at my equation, x squared plus 10x plus 25, and that's factorable now. I've created something that factors down to a perfect square. And it will always be a perfect square because we created it. We completed the square. So we created that situation. So that gives us x plus 5 squared equals 31. Now, we said if I have a perfect square, I can get rid of the square by taking the square root of both sides. So that gives us x plus 5 equals plus or minus radical 31. And so now finally, in order to finish the problem, I have to get rid of plus 5. So I have to subtract 5 from both sides. However, as we know from our radical unit, I can't add a radical and a number, so I simply move the -5 over to the right side, and we usually put it in front of the plus or minus 31, so that way it looks like a single operation problem. -5 plus or minus the square root of 31 is our final solution, and we leave our answer in that form. We could make it into a decimal, but for right now, we're going to work with radicals and do our simplifying radicals to kind of stay on that same path with what we were doing last unit.